Today is day 5 and we are going to continue from where we left on day 4. So I'm writing the things in the same Word document for entire RDD part so that once you want to read it is there in continuation. So day 5 you can directly go to page 13. So this is page 13 and we have to execute few things to continue. So first thing is we have to start up our Spark. So first thing we have to do is start dfs.sh. Okay, start dfs. Start dfs.sh. Start yarn.sh. Now hive service meta store and finally Spark. So and let us start another tab where we'll be actually working and let us zoom in a bit.
Do you have any stop script?
Sorry,
Do you have any stops?
do you have any?
Stop script?
Oh, yeah, you can just replace that start with stop.
Okay.
Okay. Anyhow, for now, you can even if you just close and power up the machine, it should be okay as well. But you can also replace that start with stop. Okay. So let's see if everything is started. This started. It's okay. This also started. This will take a while. So let's wait a while for this to get started. Okay. So this also started and let's continue. So yesterday we created one array and it were having the multiple sentences that we just took from Wikipedia. And let's create back the same array. So I just copy some part, copy paste. Oh, I have to start Spark shell. The first thing that you need to do is change the log level to error. The default is warning. So sc.set log level to error, and we want to create an array of sentences. So the name of the array is book, that is of type array, and it is having a string inside it. The next thing we need to do is, once the array is done, we did a map and a flat map. So anyone, what was the difference between map and flat map?
Flat map.
Map flat map flatten the structure and the map return array of array.
Alright, so map was giving array of array, but flatten gives you a flattened all the words. And let's say you want to do a word count, that is each of the word is coming how many number of times, you definitely want a flattened structure. So the next thing that we need to do is we want to create a flat map. So I just copy this and I say that flat book RDD. Okay, flat book RDD is equal to book RDD dot flat map and split by the spaces, right? So it should give you a flattened structure. It is giving an error because I have not written val or var. So it still gives you an error. It says that book not found book RDD. Oh, I just created an array. I haven't created an RDD yet. So I have to create an RDD by a parallelize method, right? So after creating an array, the next thing we did was we created an RDD using a parallelize method. So there are how many partitions over here? Two partitions, right? So we are having a two partition. So book RDD dot collect looks something like this. So it is having all the sentences over here. And if I want to make a flattened structure out of it, then val flat book RDD is equal to book RDD dot flat map. So it is going to make a flattened structure, and we are splitting by a spaces over here. And if I want to see the contents of it, flat book RDD dot collect. So if I see now, I am having all the words, right? I am having all the words, and we are not having any kind of an array of an array. We are just having all the words. So let me copy this. Change the font to Courier New 16. Remove the bold. So we have seen map and flat map over here. Flat map was 2.4. So let's start with 2.5 and 2.5, starting with sort. So if I want to sort this in an ascending order of the length, if I want to sort this RDD all the words in an ascending order of the length or a descending order of a length, we can do is use flat book RDD, and the method is sort. The method is sort by. And what we want to do is for every word over here, I want to sort it by the length of it. So I will say that for every word present, sorted by the length of it. Word LENGTH, spelling mistake. So if I do this way, it is going to sort according to the length. It is not showing me because it is lazy. It doesn't perform anything until it comes across an action. So I just add a collect action against it. So it is sorting as a ascending order of a length. So flatbook.sort by, and we are sorting it by the length of it. So if I want to sort by descending order of the length, what should we do?
False, cast false.
False. Okay, so if I do a false, then it will be sorting according to a descending order of a length, right? So let us copy this. Any questions in sort? Okay. If no question, then let's go ahead and see a random split. So a random split is basically needed when you are doing, it's not required for a data engineering point of view. It is required more from a data science point of view. So you will never be using this basically, random split. Okay. Someone is pinging, he is not able to connect. Uh, okay. So it is required from a data science point of view, and that is for machine learning. And in case of machine learning, how it works is whatever data you have, let's say you are having certain amount of data, and let's say this is my data, and one of the very common example there is house price prediction. So let's take some data is given to you. Just forget about this. Serial number 123 doesn't matter. Locality, area. There will be other things as well. Number of bedrooms, the number of washroom and all. So the cost, right? And you have certain data over here. Some locality, maybe Texas or New York or something else. Area is 10, 20 and something else. So there will be a lot of data about Texas and a lot of data about New York, and cost will be 100k, 200k and something else, right? So let's say this is the data that is given to you, and what you need to do over here is, given these data, that is locality and area, you will have to predict a cost. Okay, so given these two parameters, locality and the area, so area can be 10 square foot, and just all these are example random values. So square foot, you have to predict a cost. So in case of machine learning, what you do usually is you divide the entire data into 70% of the training data and 30% of the test data. You divide the entire data into 70% of the training data and 30% of the test data. So this is my test set. It may not necessary, it can be not necessary at end, it can be at end, it can be random and so on, right? So this is your training data. Let's assume a 70% and 30%. Again, what is done is, using this data, a model is built. You run certain algorithm, you run an algorithm and build a model. build a machine learning model. Okay, algorithm is nothing but some piece of a code. Model is nothing but the same piece of the code with certain parameters found, right? So it's very simple. You can just consider it as a y is equal to m1 x1 plus m2 x2 plus c, right? So this is basically x1, this is basically x2, and this is basically a y that you want to predict, right? So yes, you find the value of m1, m2, and c in a model, and that's a machine learning. So the idea is not about explaining what is machine learning over here. It's just about giving you an intuition currently that in case of a machine learning, you need to divide the entire data set that you have into a training data of 70% and a testing data of 30%, right? In a most basic way, 70% train and 30% as a test data. And you make a model on this training data, you build a machine learning model, and you basically test the model on the test data, whether the model is predicting the correct result or not, right? So the main thing from here, the takeaway should be for you is basically in case of machine learning, this is very obvious thing that you have to break the data into a different data set, 70% and 30%. One part will be called as a training data and another part will be called as a testing data, test data. So for doing this train and test split, splitting a data between two things, you can use a function called as a random split. To break the data into two things, you can use a function that is called as a random split. So let's see about random split. So we are saying that for data engineering, we will never use this random split, but for data science, for a machine learning, it is required because you need to break the entire data set into 70-30% ratio, right? 70 is to 30, train, train, test sets, right? Entire data sets you have to break into test and train set. So this random split is required from that point of view. Uh, from data engineering point, it is not required. So what we are going to do over here as well is whatever data we have in a flat book RDD, whatever data we have in a flat book RDD, this is a flat book RDD, whatever data we have in this flat book RDD, we are going to split this data into 70% and 30%. We are going to split this data into 70 and 30%. So for that, we are going to use a function or a method called as a random split. Let's write the code as val test, val maybe train test RDD. Let me write book also. Test train. Always good to write with a camel case so that it's good to read. Or else you can also use an underscore in between. So I say the final output variable is this. So the contents is there in the flatbook RDD. Flatbook RDD dot a random split. So I want to do a random split on it. And in a random split, you need to define how you want to split. What is the percentage you want to split? And to define that, you have to define it as an array of a double. So you have to define it as an array of a double. And you say that I want to split as a 70% and 30%. So let's understand what this does is it takes the flatbook RDD, that is, it takes this RDD, applies a random split method, that is, it is splitting it into multiple parts, and you have to specify basically array. You have to specify the percentage in a as an array of a double, and you are specifying that 70 and 30 you want to split it into. And let's run this. So it is done. And if I want to see the contents of it, I will just use this and you can see that the final RDD is also formed as an array. The final RDD is formed as an array. Okay, so it is having an array because there are two data set. One is a test data set and one is a trained data set. So if I want to see the first data set, I will just say that 0 dot collect. So it gives me the 70% of the data, and if I run the same thing with a 1, it will give me the 30 remaining 30% of the data. So let's iterate again, repeat again. What is the function method that you will be using for splitting?
Random split.
Random split. And the percentage you have to define in what kind of a variable type?
Double.
Array of a double. And why I have to write 0 and 1 over here?
Percentage of split.
Sorry,
Percentage of split.
can you come again?
Sorry, can you repeat your question?
Why we have to write this 0 and 1?
Oh, that is a return array of
Right,
two data sets. One is the
right,
70%, another is 30%.
right. So yeah, you have to. That's correct. So there were it was returning at two things. First as a 70% and second as a 30%. So let us copy this as well and write something splitting as 70-30% returns array of RDD. Right, it returns a array of RDD. Okay, it returns an array of an RDD. This is the first instance. So we have put a first 0, and this is the second instant, that is 1, and it was having a 30% of the data. You can just make it out that it is split into a 70 and 30% of the data. Okay, let's go ahead. Any questions until now? Any questions here? Okay, so
Uh,
what were we? Yes, yes,
can I ask
yeah, sure.
one question? When we did the random split, it returned a array, but the other things also it array other things I'm not sure I understand the return actually. What it is basically the returning the train test book RDD
Mhm.
other elements. Yeah, there's that bit.
Okay, so over here,
Yes, yeah,
the
it returns something. Yeah, when you created it, it returns something that is the array and other elements. What is this?
where you are referring to other elements,
When you executed that line of the statement, val
right,
train book array, and it returns something. So you look
right.
at it, next line. Yeah, next line. Yes, I'm talking about this statement. This is the output.
Mm-hmm.
What is this output is they explained us.
Okay, so first thing is it just says about what it has written to you, right? So what this function has written. So this function has returned you something in this field, that is train test book RDD. So this is a train test book RDD. If you see this colon, it explains that what is the data type of it. So this test train RDD is having this data type. So this is a data type. What is a data type? It's an array, and inside a array there are RDDs, right? So there is an array of RDD. So there are multiple RDDs inside it, right? And second thing, multiple RDD, but how many RDD? You can find it from here. It is returning an array. This is its first RDD. Okay, this is the first RDD, and this is the second RDD. This is the first RDD, and this is the second RDD. So it basically says that it is returning this variable. The type is array of RDDs, And how many RDD? There are two RDDs or two elements present in an array. Again, the console 25 and map partition RDD 17 and 18. This can be referred over if you start the UI and you see over there. There also you will see the same number. So basically, map partition RDD 17 and map partition RDD 18 is for the reference for how internally it is doing and where it is keeping that partition. So if I start, look for a here, completed job console 26. So this is about random split, and you can see that this is for 18th. So this is for 18 because this is the one that we 18 was the second one and 18 was printed over here. So since this was the 18, you can see the 18 as the latest one. If I go back and if I see the previous one, it should be for 17. So you can see that this is for 17. It created what?
Two DAGs.
Two DAGs, yeah. Two DAGs. The two DAGs that we saw was one is for this DAG and one is for this.
Okay, okay, okay. Yeah.
So there will be multiple. This will also have
Yes.
one. So if I
One. Yeah.
see this one, this should be a one previous to it.
Uh,
So this is a one previous to it, and parallel correction RDD 0 collect at say console 26 and console 25 doing a flat map. So for this one is this two completed tasks. So these are the two tasks that it completed. Then if you see the previous one, this one was sort by. So every instruction that you will run, you can see it over here. So this is for the previous one.
yes, now I realize it created a DAG, but the split, the random split, actually it is a transformation, so it didn't create anything.
Yes.
Yeah.
Yes. Right. Okay. Perfect. So whenever you run this, another thing to note over here is since this is a transformation, it will never run this one. But when you run this, it will run this one time, and when you run this again, it will run again second time. Okay. So when you say
It
it's
will transform and do twice basically.
yes, it will do a transform twice. So one more thing to note over here is since we came to this point, anyhow that point will come out again later when we study about caching and persist. But for
Mhm.
now, again since we already saw this DAGs, so we see that there were two over here. It was not one because every time you did the transformation, this is not executed. You did this transformation, you did this action collect, it led to the execution of this transformation. Again, you did this collect, it led to the execution of this transformation again, right? So you can see over here that it executed again the same thing. It did the random split again. Okay, if I click on the first one and if I click on the second one from the top, it did the random split again over here, right? So though I wrote the random split over here only one time, the random split was executed 2 times because the transformation will be executed every time an action is called. Okay, is it clear? Any doubts?
Yeah, good.
Okay, so the conclusion is that we see that random split is executed both the places, over here as well as over here, because transformation is called every time the action is called. Okay, any other questions, anyone?
No.
Okay, perfect. So let's go ahead and let's see about actions. So action is nothing but the one that starts the transformation, right? Or it kicks transformation. So transformation is lazy. Whatever transformations we were writing, it was lazy, right? It was not doing anything. So every time we were writing a transformation, we were writing a collect also, so that we could basically see what is happening, right? So collect or action is something that actually starts the transformation. The simplest example of an action is of course the collect. So what does a collect do is, collect is going to do nothing but it is going to get the data from the executors into the driver and just display over here dot collect. So what does a flatbook RDD dot collect does is, the flatbook RDD is basically an RDD which were having two partition. You remember at the time of parallelize we said it has a two partition. So what does this collect does is, collect basically gets the data from both the partition and it displays on the console. So when it is displaying on a console, basically it is getting the data from both the partition into the driver and it is showing over here, right? So the simplest example of an action is a collect, which does nothing but gets the data from all the partition and basically it is displaying over here, right? Okay, any questions over here? Okay, if no questions, then let's go ahead and we see the next example for a reduce. So for reduce, let's see sc dot parallelize. So parallelize is basically the method to create an RDD. Let's say I'm creating a RDD from 1 to 10. So that is having an numbers from 1 to 10. So it will have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Then we execute a reduce and we say that underscore plus underscore. So what is this underscore for? What do you mean by underscore?
Placeholder?
Underscore is basically a shortened notation, right?
Shorten. Yeah.
It is a shortened notation. So what does a reduce do is, it takes next two elements from RDD. Okay, it basically takes the next two elements, or I will say next one element or next element, and adds, subtract, whatever, with the existing result, right? So let's try to understand what does it mean. So let's say 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 is the 1, 2, 3, 4, 5, 6, 7, 10 is the contents of an RDD, right? Let's say RDD has this value 1 to 10. So if I do a reduce, basically what it will do is, it will take these two elements and let's say I'm doing a plus operation, right? So it can do any operation and perform operation. Okay, perform operation example adds. So it will take these two elements and it will add and get you a result. Then it will add something this element and get you a result, right? So let's say if it adds the first two elements. Okay, let's instead of this, let me write so that it's more easy. Later on, I will. Uh, so let's say RDD is having an element. RDD is having the value is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So what will reduce do is, let's say I do a reduce underscore plus underscore means it will first take the first element and get you 1. Next step, it will take the next element and add with the previous element, right? So it will add these two elements and give you what is 1 plus 2? What is 1 plus 2?
3.
1 plus 2 is 3, right? Okay. So what will it do next? It will add this 3 with whom?
3.
And it will add this 3 with, and it is going to perform this plus operation, right? Why it is performing a plus operation? Because it is given over there as a plus operation. So it is doing a plus operation. It's doing a plus operation and gives. So 3 plus 3, what will be the result?
6.
6, right?
Yep.
Okay. Next. Next, it will take what? What will it take next?
4.
6 and 4,
4.
right? And what operation it will do? Plus,
Plus
right?
operation.
Because the plus is given over here. So what will be the result?
10.
10. Then 10 plus 5?
15.
15. 15 plus 6?
21.
21 plus 7?
28.
28 plus 8?
36.
36 plus 9? 45
45.
plus 10?
45.
55. So what does a reduce do is, basically it takes the next two elements, and it basically reduces it. So 1 plus 2, 3. If I say plus, okay, so it goes on reducing it, and the final output will be 55, right? So the final output will be 55. I basically copy this and keep in the same notes if it is able to paste here. So I have added the explanation over here for your future reference. So basically, sc.parallelize is going to create an RDD with the element as 1 to 10, and it is going to reduce it underscore plus underscore. And what will be the result for this? What should be the result? 55, right? So it has reduced it to 55. Any questions over here? Any questions? Okay. No questions. Then we will go ahead and write a program, or maybe write instruction to find the shortest word, or maybe write a program in Spark to find the shortest word from the book, right? So what is the smallest word in the book? What is the smallest word in the book? So we want to write that program, right? So I will not start with the start, but we had already reached till flat book RDD dot collect, right? So all the words in the book is available over here, and what I need to do is I want to write a program that is basically going to find the smallest word. So how are you going to find the smallest word? Is it the same thing that we just discussed over here? Will we also consider a first word and second word, and just take which is the smallest word, and then take that and compare with the next word and see what is the smallest word, and next word and what is the smallest word, and next word and the smallest word, and so on, right? So basically we are doing the same thing. We are just comparing between the two words, and finally we want a smallest word. So if finally we want a smallest word, we can also use a reduce, right? We can also use a reduce. So, but will I be able to write it in a so small way? Can I write it over here? Can I write the same thing over here inside the function? Can I write over here? Or it is a more complex logic?
Mm,
Can I write over here, or it's a more complex to write over here?
No, we cannot.
We cannot write. I mean, we can still write it, but it will be looking
Take
very
from.
dirty.
Yeah.
So what we'll do is we cannot write over here. Since we cannot write over here, what is the other option?
right, function.
Create a function, right? Create a function. So what I will do is def, def meaning I am writing a function, and what can be a name of the function? Smallest word. Okay, so the name of a function is smallest word, right? So the name of a function is smallest word. Okay, so I'm saying def smallest word. Okay, what should be the input parameter to it? What should be the input parameter? Will it take these two words and compare? Right? It will take these two words and compare. Then the smallest of these two words and this word and compare. Then smallest of this word and this word and compare. Right? So let's say if it is going to take these words and compare. So what is the data type for this word? What is the data type for it?
String.
String, right? So basically it has to take a string, right? You should give the answers so that it's more interactive.
Yeah.
So it is basically you have to take the words. So I will say that you have to take the first word and second word, right? So I will just say as a left word. And what is the data type of this word?
String.
String, right? So I am saying that left word and right word
String.
string, right? And for this particular function, Acha, let's say about this. So when we were doing about these two, input was an integer. What was the output?
Integer.
Integer. Okay. So for this one, we will take left word and right word. And what will be the output for this function?
Either word or boolean.
Word, right? We'll take as a word,
Word.
and
Yeah,
we
word
want to
and yeah,
compare it with
word.
another word, right?
Again
Yep.
string.
So we'll take as a word, so that because we want to compare this with another word, so the output will be again string. Okay. So we want to take the left word and right word, compare, find the smallest word, give it as a output. Then again take a output, compare with the next word, again give a output, right? So the output will be string as well. Okay, great. So how do I compare two words? How do you say the is small or history is small?
The
Length, check the length.
Length, right?
compare.
So I will write something for a length, right? So what will I write? If left word
Dot.
dot length is greater than right word dot length. If I do any spelling mistake, correct me please. So if the left word is greater than the right word, if the left word is greater than right word, then I want to give the smallest word. We are finding the smallest word, right? So which is the smallest word, left word or right word? So what shall
Right
I
word.
return?
Right word.
Right word, right? So if the left word is greater than right word, I want to return the right word, because right word is the smallest. And else what I have to return?
Left word.
Return left word. Okay, return a left word. Okay, perfect. So is this function clear?
Yes.
Okay, so basically we are taking two words, and if the first word is greater than the second word, then return the second word, else return the first word. And can you suggest me how to write the reduce function now? What is the RDD you want to run the reduce function?
Flat book RDD.
Flat book RDD. So flat book RDD. And what is the function you want to run?
Reduce.
Reduce. Okay. And what shall I write over here?
Uh,
What is the name of the function? Where is the logic?
smallest word.
Smallest word,
Smallest
right?
word.
Smallest word. Okay. Smallest word. So what is the smallest word? A dash is a smallest word. So if you look into this one, there should be some dash over here. This one, right? So this is basically the smallest word, right? Is it clear? Any doubts in this? Any questions in this?
So by default, the reduce function will return will send the first two words to the function, right?
Right. It will take the first.
So we don't have to, they give the shorthand notation here, like underscore dot underscore here. We don't need that, right?
Okay. Over here, if we are writing the logic over there itself, if I am writing the logic over there, if I want to write a logic over here, then I can do underscore underscore. So I can say that if underscore meaning what first word,
Yeah.
okay. So I can write something if underscore, that is first word, is greater than underscore, okay. So it will become very bad. So if I want to do
Okay.
over here, if underscore is greater than underscore, okay, if underscore is greater than underscore, how do I depict a second underscore also? Then probably a return a second underscore, right? So it will get even more bad. If better give if x is greater than y, okay, if x is greater than y, return y, okay, if x is greater than y, oh no, again if should be if x dot length, right? X dot length is greater than y dot length, then return what shall I return? Y, right? I have to return y. Else return x, right? I hope it is correct. It gives you an error and it says that return outside the method definition. So okay, so I don't have to write return
We'll
x
just X here.
else y. Okay, so what does it give? Not found the value x. Okay, then x comma y, because I am not writing underscore shortened notation. So it will become very complex. Let's still try to do it. If x dot length is greater than y dot length, y else x,
X.
one more bracket. Okay, so you can
Yeah.
also do it this way, right? But I mean, it is not even readable properly, right? So I will still copy it over here, but don't do it right like this unless
Yes.
you want to trouble the next person in your job role, that he should not be able to understand anything. Okay, define the function. Okay, any other question? Define the function. Then call the function in the reduce method. Okay, and this one is definitely not so good way of doing. Okay, so but this will also work. Okay, if I want to find the biggest word, then what shall I do? What
You
will be the
can
changes if I want to
change
find
the
the longest
return.
word?
Whichever word that we are returning, we just
Or
change this.
just change this left and right over here, right?
Yes.
So either just change over here, or maybe you can also change the sign from greater than to less than. then also it will work, right? So either you change these two words, or you just simply make this greater than as less than, then it will give you a largest one. Let's not go over there, and let's go to the next method, that is count. So what does a count do, anyone?
Is the number of elements of an RDD.
Count gives the number of elements in that particular RDD. So it is 100 number of elements, right? So if you count this total, so it should be some 100 words that is present in this particular RDD. So count is a self-explanatory. It gives you the number of elements in the RDD. Okay. Then, okay. Any questions in this so far?
No.
Okay. Then there is another function for count, that is count approx. And what this approx does is it gives you an approximate count values. It gives you an approximate count value. And what you can do is you can just simply specify that I want the count value maybe in 100 milliseconds. So whatever count value you are able to give, you should be giving me 100, but I want it in 100 milliseconds, or I may want it in 80 milliseconds. It may not be accurate, then also it's okay. Okay, with 80 milliseconds, it is able to give the correct 100. Let's make it even less. I'm saying that give me the time, give me some count in 50 milliseconds. It's still giving because it's a test data, very small data. So if I simply do it 10 milliseconds, I'm saying that give me a count in 10 milliseconds. Then it is saying that the count is between 0 and infinity. If I change it to 40 milliseconds, it's able to give 30 milliseconds, it's giving 0 and infinity. 38 milliseconds, it's giving 35 milliseconds. It's giving 32 milliseconds. It's giving 31 milliseconds. It's still giving 30 milliseconds. It's now it is giving in 30 milliseconds also. 28, 25, 21 milliseconds, 22 milliseconds. You can just play with it, because since the data is very small, so it is either giving me in 0 to infinity or giving 100 to 100. But ideally it can also give you some particular limit, like it is between 90 and 100. Okay, it can give you that it is something between 90 and 100. So count approx is another way to get the count. If you don't want the actual count is okay, but you want an approx value. So if you want number of customer who actually did the shopping today, it's okay if you don't get the actual count, because the customers are actually shopping today. The count is definitely going to increase, but I don't want to just put a count and wait for so long. I can just say that count approx, and it will give me that okay, approximately 1 million people have done the shopping on my e-commerce platform. So this count approx is another thing which you can play with, which basically gives you what is a count in 25 milliseconds, right? Count returned in 25 millisecond timeout. Default confidence interval is 95%. So it is confidence interval is 95%. So with a 95% confidence, it is saying that the count is between 100 and 100. Over here 21, the count the with 95% interval, it's saying that it's 0 to infinity. So 22 milliseconds it fails, I will say that, let's say the confidence interval I just want with a 50% confidence interval. So I can also say with 10% confidence interval. So with a 10% confidence interval, it is saying that the count is between 49 and 50. Probably it could only look into the first RDD because it is first partition. Okay, so you can also give a confidence interval also over here. So I will just write over here as uh, with 22 milliseconds timeout and 10% confidence interval, the count is between 49 and 50, right? Actual count was what? Actual count was 100. Of course, you will never give a 10% confidence interval. You will at least give 90 or 95% confidence interval. It's just I am trying so that can show you the values it is fluctuating, right? Any questions over here?
Where exactly do we use, this function? I mean, like in real projects, do we really use counter procs? Is there a use case for this?
Again, in programs you will not use, but let's say you want to um, look into, let's say there are logs and you are doing a log analytics, and it's a very flat log. It's just like a text document, and what you are doing is you are reading 1,000 of log files or even million of logs files that are generated out of certain process, right? Maybe by testing something there are logs generated, and in that log file you want to say that how many number of times a particular error came today. You can just do a count as well by loading the log files into an RDD and separating each and every word, then filtering it how many times that particular word came, and then after that doing a count. So instead of doing that, you can just give a approximate number as well, because if the count is really taking a long time, you can save some amount of time.
Just to get a fair idea of what could be the process,
Right,
rather than waiting for the whole thing to load. And then,
right. Just to get a fair idea of something. Okay. Okay. Any other questions? Okay. So let's go to the next thing. Let's see 3.5 count by value. So let's say again write a program to find number of times each word comes in a textbook, right? Whatever. So I already have flat book RDD. Okay, flat book RDD dot collect. So this is my RDD, and I want to find how many number of times a particular book word is coming. That is this particular word, the history of textbook. Each of the words are coming how many number of times. So I want to find a program to find how many number of times a book is coming, right? So we said yesterday or in the previous session as well, the most basic things that you are going to do in you want to do is basically want to find a word count program. The most basic program you do in a big data or a distributed computing is a word count program. So this is a word count program wherein we want to do this. We are doing this basically finding each of the word is coming how many number of times. Just like we do a print hello world, we do a word count in big data because that is able to illustrate the distributed data processing. So if I want to do the same thing, I want to find each of the words are coming how many number of times. So what I will do is I will just say I have separated it already into the words using a flat map, and I have a flat book RDD, and I am just going to run a method that is count by value, flatbook RDD dot count then by value, count by value. So flatbook RDD dot count by value. So what it is saying is flatbook RDD dot count by value is giving you that this word came one time, this word came one time, the in came four times, Greek came two times, and so on. Alright. So you can use this to find how many times each of the words are coming, right? For example, printing came three times and Greek came two times and so on. Is it clear what does a count by value does? Any question in count by value, anyone?
Does the output give the full list?
Yes, it will give you the full list.
Because there is after tran dot is there. That's why.
Right. If you return into something else, you will get a full list. But to show in a console, it will show you the limited number of lines only. If it is a very big, then it will fill up your whole console. But it is having the full list.
This is no different than word count, right? Or
Yeah, there is the word count only, right?
okay,
There is
there
the
is no
word count
different.
only.
Okay,
You are fine counting each and every word how many times it came.
okay.
Okay, any other questions, anyone? Okay, so if no questions, then we'll go ahead. And we have seen count by value. Similarly, you also have a count by value approx. So what does a count by value approx do?
Based on the time in the future.
Based on a time
Like,
interval, it will give you some arbitrary value. So let's say I say type 25 milliseconds and 1000 milliseconds. Okay, 25 milliseconds it didn't return anything. It just returned nothing. So let's make it a 500 milliseconds. It returns 100 milliseconds. It returns 50 milliseconds. Also, it returns something. But you can see that in is 4 time. Again, 50 is giving you a good result itself. Let's say I do a 20 millisecond or 20 milliseconds with a confidence interval of 50%. So it's not able to give in a 20 milliseconds. Let's say 40 milliseconds and confidence interval of 50%. It is able to give you the correct result. 30 milliseconds with 50% confidence interval. Still giving you the correct result. Okay. So basically, so I will just write it as so 30 millisecond timeout and 50% confidence interval. You can just play with it with different things. Any questions in this? Okay, if no question, then let's go ahead and let's do a first. So what will this first function do?
first,
It will give you a first record, right?
well,
So what was the first record? Of course, it was, let's see, collect and then again run first. So the first record was what? The, right? So the first gives you the very first record in that particular RDD. First record or whatever word or whatever string in RDD. So okay, let's go to it. Next one. Max. sc.parallelize. Let us create a 1 to 10 dot max. So what will this give? What does sc.parallelize do?
It will create RDD with 1 to 10.
1 to 10. And what will max give?
10.
Maximum value
10, right?
10.
Okay. So if there is also, you can give it a bracket and without bracket if there is no parameter. So just note this, right? You can give with or without bracket. It doesn't matter. So it's a self-explanatory, gives the max. Okay, max value. So uh, again, there has to be minimum also. So what will minimum give?
1.
1, right? So it gives you a 1. So I just gives min value in RDD. So I just copy this and let's go ahead fast. So nothing much to explain. If I want to find, there are few other methods like take, take ordered and top. So let's have a look into this first. Take, top, take ordered and top, right? So again, can ask interview question, but I haven't seen this questions being asked. But it is also a good question. But people don't work on such kind of problems because even the interviewer, if he is working, then he is working on data frames and not on RDDs. So may not ask this question. It's a good question. What is the difference between take ordered, and top, right? So what I will do is I will just create an RDD out of some random numbers, right? Sample RDD is equal to create an RDD. What is a method?
SCC.
Sc dot parallelize, right? Sc dot parallelize, and I want to create an RDD out of some numbers. I will just mention those numbers as a list, and I can just write 9, 6, 7, 5, 3, uh, 10, 25, and 9, and 35, and let me write 70 over here. Okay. So I have made a sample RDD over here, and if I want to see the contents of it, sample RDD dot collect, again can write bracket, cannot write bracket is okay. So these are the contents that are present in a uh, RDD, right? So if I am going to say it to use a method called as a take, so what take will do is just take will give you the whatever number of words you say, it will give you from start. Okay. So let's say I say sample RDD dot take and I say 3. So what take will do is it will give you the some number of words from the or some number of elements from an RDD. In this case, some number of integers from the RDD. So it is giving you certain integers. How many integers it will give? In our case,
3.
3. So if I do a sample RDD dot take 3, what will be the output?
6, 7, 5.
6, 7, and 5. So it is going to give you a 6, 7, and 5. So is it 675? Yes, perfect. There is another variant called as a take ordered. Okay, so take ordered. So any guesses what take ordered will do? What will a order do? What does a order by
Sort,
does in SQL?
It will
sort it
sort
and
it.
In a ascending order, right? So it will give you certain numbers in an ascending order. How many numbers it will give in an ascending order?
3.
3, right? Because you are giving in parameter 3. So can you say me what will be the output for this thing take ordered 3?
3, 5, and 6.
3, 5, and 6, right? 3, 5 and 6, right? So let's see 3, 5 and 6. 3, 5 and 6 came, right? Is it clear? Any questions in this? Okay. So let's see the another one, top. So can you say what will a top 3 do?
The highest three numbers
Highest 3
value.
numbers, right? So what are the highest 3 numbers over here?
70, 35, and 25.
70, 35 and 25. Okay, perfect. So 70, 35 and 25, right? Any questions in this? So I'm taking random examples so that it is a simple examples. So take 3 will do is take first 3 elements from RDD. Okay, this will be ascending order. Okay, 3 elements because you gave this 3 over here, right? 3 over here. So over here is ascending order and over here is a descending order. Okay, any is it clear? Any questions over here? Okay, so this is about the difference between take, ordered and top. You can also run it on the flat book one as well, but over there the result will be a bit difficult to explain. So we took this simple example, but you can also run flat book RDD. Take 3 will take the first 3 words, the history of. Of course, if I scroll up, the first 3 words are the history of. So take is giving me the first 3 words. Top will give me an ascending order. So it gives me ascending order. Uh, no, top will give you a descending order. So the ASCII value is maximum for this, then the ASCII value is maximum for this, right? And take ordered. So take order will give you ascending order in the ASCII value. So ASCII value for 1450, 15 is less, 1 is less. ASCII value is Bible is next thing. So uh, I did not take this example because it's difficult to interpret, but I will still copy this. You can just ignore this example if you want. Okay. Any questions over here? Okay, if no questions, then let's go ahead and there is again one more thing that you can do is take sample out of it. So take sample. Okay. So take sample is going to take a certain sample of the words from it, and there are basically 3 parameters for it to give. One is the whether you want it with a replacement or without replacement. The second one is the number of words that you want, and the third is the seed that you pass, so that if you want it to be a consistent or not. Let's see with an example. The first is whether you want a replacement or not. We'll see what each of the words means. Then the next thing is how many words you want. Let's say I want a 70% of the data, so I want 70 words, and you can give a random seed. So what this take sample will do is it will just take the 70 words from there and give you it over here, right? It gives you a 70 words over here, right? So let me write 3.11 take sample. So let's try to understand each of the things, what each of the parameter is over here and what is the use of each of the parameter. So first parameter that we gave was true, meaning we wanted with replacement. The second parameter we gave was 70. So these are the number of words that we want. And the third parameter that we gave was a seed. That is, we want a seed as a 10L. So this true means I want it with a replacement. That means if I take a word off, if it came one time, it can also come second time. It can also come third time. It can also come fourth time. Okay. So if I see off, it is present one time. It is present two times. It is present three times. It is present four times. Uh, it is present fifth time. It is present six times. Okay. So with replacement, because the same word is put again, so the same word can come again, right? So we see that off is coming same time. Okay, so I will just write an explanation. Since replacement was on was true, okay, since with replacement was true, off came seven times. Okay, but if you see the original RDD, the off was present how many times? We also did a word count, right? So in word count, can we see off was present how many times in a word count? MNOPQRST. Can I find the word O of? Maybe let's count it over here. How off was there? How many times? So off was present one time. Off was present two times. Off was present three times. Off was present four times, right? So off is only present four times. Off is present only four times. But how many times off came? Seven times above, even when in the entire data off was present four times. Why it came seven times? Because of the fact that it is with replacement. So every time it will take off, it will put back the off again and it will take again, right? It is just like you have to take some balls out of the bucket, and once you take out the ball, you have a bucket with a red and yellow ball, and you take out the ball and you put it back again before drawing the same ball again, right? So it's just like what do you mean by replacement is you have a bucket and you have a two balls, red balls are three and yellow balls are two, right? Four and two. So I can take out, whenever I take out a ball, I just see the color and I put it back, right? So that's called as a with replacement. If I'm putting back the balls again inside, it is called as a with replacement. I see the color and put it back. So a yellow ball can come infinite number of time. But if it was with a replacement, without a replacement, it will come only two times. Okay. So with replacement meaning I could take out the ball and put it back. Right? With replacement means I take out the ball and put it back. Without replacement means I take out the ball and I don't put it. So if I do a without replacement, the ball, the first ball I take, it will be only this much left, right? So similarly, if I do a with replacement, it is possible that the same word can repeat. Even the off came seven times. If you read over here, off came seven times. But if the off was present only four times in the entire word. So is it clear? If I do a false, if I do a false, you will see that off will not come more than four times. One time, two time, three time, and four time, right? So off is only coming four times. So is it clear? Any questions in this? Why the off came seven time and over here off is coming four times only? Is it clear? Any questions in replacement and without replacement? that is a max number of a times that a word can come, because there are only 4 of. Okay, so is it clear? Any doubts in this? Okay, no doubts, then let's go ahead. What does this 70 means? What
Number
is
of
this 70?
random,
Sorry?
number of random words that are
Yeah,
picked from
number
the.
of words that are picked, right? So I can just reduce it to 5. So I will only get a 5 words. So it's self-explanatory. Then any idea what does this 10 means? A seed. What is the use of a seed?
To have the same data set repeated
Right.
the next time when
So
you
to get the same sample every time, right? So this seed is very, very important thing, especially in machine learning also. The speed is very, very important in order to get a reproducible results, right? So if I don't give a seed, then every time I do, I get a different 5 words. So you always have to give a seed so that you get a better words, right? So seed is important for a reproducibility.
What is the L in L mean actually? 10 is the number, and what is the L
L
for
stands
stands
for a
for?
data type that it is expecting. So this take sample is expecting a long data type. So if
Okay.
you just go into the GitHub Spark take sample. So if you are going to go into a GitHub and going to look for a take sample function, take sample. Okay. So take sample is having a with replacement, that is a boolean. Uh, Numbers of the thing, that is an integer, and seed it is expecting a long. So it is, you have to give in a long, and if you don't give, then it is going to take a random seed it is going to take. So always give a long, else it will take a long. It's a L meaning long data type. Okay, any other questions? So either you can go and look into the directly into the code base. It's a open source, and or else you can also look into the spark.org documentation, their website. So this is Mate Zaharia, who made the Spark in his PhD project. Okay. So he has also written this program as well. And there are so many contributors to this program 106. And it was the last commit was 25 days ago. Go into history and see. So some changes and so on. So many changes. Okay. So any other questions?
In the command line, can you see the in the command line? Can you see the function definition as a help text?
As a help, right?
Yeah, as a
Uh,
help. Is it called?
you can see what are the functions that can be applied. Then in basically if you're writing in an IDE, it will automatically give you over there. I'm not sure if there is any way to check in, like in Python you can do a question mark and it shows.
Yes, yeah. And alt tab, shift tab also sometimes they give up the some
Shift
of the
tab gives the
the.
completion only, I believe. Shift tab is a completion in Jupyter. I don't think so. It's there, but if you're writing in an IDE, then it should give you. If I do a text sample, oh, it gives. If you do a tab again, so
Okay, tab
tab,
will give. Okay.
yeah, so you have to do tab 2 times. So Bit replacement boolean num integer, and this one is the output, that is array of strings. Okay. Any other questions? Okay, so I will just copy these two, saying that uh, node below, if you don't specify seed, it will give you random values. Okay, and that's it. Any other questions? Anyone? Okay, if no questions, then let's go to the next method. So you're done with 3.11. Let's go into 3.12. Save as text file. So if I want to save it as a text file, so I'm having a flatbook RDD, and I want to flatbook RDD save as text file, and let's say I want to save it in my Linux. So let me open another thing, and let me zoom in, and let's say where I am, pwd home Hadoop user, and let's make directory, make dir temp 2012-25, temp 2012-25. I'm making a new directory, and I'm going into there 2012-25 cd y, oh, spelling mistake, pwd. Okay, and I am into this directory, and basically I want to save this contents of RDD over here. So I say that save it over here. So I'm saying that flatbook.rtd save as a text file, and store it over here. So it should have stored into this location. And if I do ls alter and okay, Hadoop home Hadoop user temp 2012-25. Okay, then the default part should be in HDFS. My bad. So let me look into HDFS, DFS slash HDFS, sorry, HDFS DFS ls dash slash. So HDFS DFS meaning I'm running a Hadoop command, and ls meaning I want to list something, and can I see some folder with the name home? Okay, so it is stored basically over here. So I give this path by mistake. So this is basically going to store over here. So HDFS DFS ls and paste. So I'm doing that Hadoop distributed file system, ls meaning list everything that is present inside home Hadoop user temp 12 2012 25, and you can see that it has stored over here these things, right? So let me make it big for a minute. So if I do HDFS DFS ls home Hadoop user wherever the path it is saved, you can see that the three files are created. So can you just say why this success file is created?
The job is
Job is completed successfully. So that
yeah.
if next job is depending on the output from this job, it will basically look that is the success file there? Okay, is the success file there? First thing. And second thing, is the success file of the correct time what I am looking for? That means the output is there in there, right? It's properly placed. So this success file is very important for the job scheduling, so that if the next job that is triggered should be triggered by looking into a success file at the time of the success file. Okay, next question. Why it has two different files?
Two mappers are used.
Sorry?
I think there are two mappers that are used for this. Two
No, no
partitions.
mappers. Now there are no mappers, right? Mapper was
I
a,
mean, two partitions.
yeah, two partitions, right? So there were two partitions over here when we created an RDD. RDD was having a two partition. If I want to see the contents of this HDFS DFS dash cat, and I just do this. So it will have some half of the book, and it is having the half of the book. And if I see this one, it will have the next half of the book. Okay, so half of that book, right? So is it clear? Any questions in this so far?
If we had specified the number of partitions, by ourselves, so let's say we specify four partitions, then we would have had four markers, right?
Alright, alright. If you specify four partition, you will get four. So just copy it over here as the output, and this is what I did. Okay. So just check the output below. Three dot 12. Okay. Any questions in this? Okay, if no questions, then let's go ahead. The next thing is very important, cache and persist. Okay, this will be a sure short interview question. Sure interview question. Okay, I mean you will get to see this question at least 7 out of 10 interviews, or at least 6 out of 10 interviews. Right? What is a cache and what is a persist, and why you actually need this, right? Okay. Just give me a minute. I will be back.
Yes, Hari.
Okay, perfect. So yeah, we were to start about cache and persist, And this is very sure shot interview question for sure. It will be there, or most of the times it will be asked. So let's go back and see what we did for a test train split. And okay, so test train split, test train train test work RDD dot 0 dot correct. Okay, so this random split, is it a transformation or an action? Is it a transformation or action?
Actually.
What is this to collect? This is a transformation. Random split is a
Oh,
transformation.
sorry.
Collect is
Sorry.
a action, right? Okay. So will
Yeah.
the transformation will be executed, or it will be executed only upon action?
Only upon action.
Only upon action, right?
Yeah.
So this transformation was not executed. However, behind the scenes, the Spark is taking care of how to make a graph, and it keeps it with himself, but doesn't execute. Then when the collect comes, it executes that particular graph, and the first graph is executed, and the same is executed on the second one. This is also executed again. So there is a transformation, there is an action, this is again a action. So once this action was executed and this action was executed, this transformation will be executed how many times? One or two?
Twice.
Two times.
Two times, right? But since I know already that this is want to execute, we want to execute, but it is executing two times. So what is the option that we can do so that it should not be executed, right? It should not be executed again. Okay. So the answer to that is you can do a cache. You can do a caching. So what the cache will do is cache is going to execute whenever it is executed, it will keep in a memory. Cache is going to do is whenever it was executed, whenever this transformation is executed, it will keep into the memory. It will keep in a memory. It will keep in a memory and make sure that when the action is happening on the same RDD again, the data is already present in a memory, right? So what does a cache do? It solves this problem. What was the problem over here? What was the problem over here? What was the problem over here?
We were fetching the same result twice when it was needed just once. I mean,
Okay. So the
I've saved
problem
it.
was, problem is in below code. What was the transformation name? Random split transformation is executed two times because two actions. Okay, I mean the collect action only two times because collect action is called two times. Okay, but what is the solution to it?
Can cache it in the memory.
So the solution is caching. So the problem over here was it was executed two times and the solution is caching. Solution use cache. Okay, so if I go over there and see, if I go over here, I go into, I refresh it. Okay, so these are the two places where it should have been executed. So there was a random split on the job number 78 and job number 77 again there was another random split, right? So what is the solution now? do a cache. So let's try and see how does a cache work or not. So I just say this and I say that train test book RDD dot cache. Okay, I do a cache. What's the problem? Cache is not a member of array. Okay, it is written as an array. I cannot do a cache to an array. A cache can be performed on an RDD, but this test train is actually an array. So I will have to not take the example of this one because this is an array. I will have to take an example of some other thing which actually returns RDD, right? Okay, so let me take an example of a flat map. Flat map. I cannot take the example of this because this is giving me an array, so that's not a good example. The cache will not work on this, so I will take an example of a flat map. Okay, so where is the flat map? Flat map. Flat map over here. So if I copy this and I'll remove this example and I will give a different example because the cache can only be done on an RDD. So flatbook RDD, this is a transformation. Flat map is a transformation. It will not be executed. And if I do, let's say I want to do take 5 and I want to do a top 5. Take 5 and top 5. These are the two things I have to do. Take 5 and top 5. What is take 5 and top 5? These are the action. This is a transformation. But if I go into this again, jobs and see the latest two jobs, one for a take and one for a top. Okay, first 79. So can I see the flat map done over here? Is the flat map done?
Yes.
And what was this action? What was the action?
Take.
Take, right? Okay. Let's see for another action. This is top. So for top, is the flat map done again?
Yes.
Yes, right? Flat map is done again for a top and flat map is done for a take also, right? So for both the jobs 79 and 80 for take and top, it's done 2 times. So there is a good example. I mean, this is the example and I will just copy it. And what we see over here, uh, I say what is the transformation? Let me correct it. So we say that in below code, flat map transformation is executed 2 times. Uh, one time for take and one time for top, right? So we just saw in the UI as well, it was executed 2 times. Now let us modify a code a bit. I again do the same transformation what I was doing a flat map, and but I do this is flat book RDD dot cache. Okay, flat book RDD dot cache. I'm saying that I want to cache this. So whenever I come over here, I'm going to cache it and keep it. Now again I do a take and I do a top. Okay, so I do a take and I do a top. One thing I do extra is a cache. So what this cache will do is it will make sure that this transformation is executed only one time. It is executed only one time. Whenever it does a take, it will execute. But when it does a top, since it already has the same thing in a memory, it should not do it again, right? So let's validate it from the UI. So let's take a job and we replace it. Now this is a take at 81 and top at 82. Okay. So if I see a take, can I see a flat map in a take?
Yes.
Yes. Why I can see a flat map in a take?
Because this is the first time that you are doing
This
it,
is the
so
first
it's
time.
getting.
Okay, now if I see the next one that I run top, so why does a top, okay, what this top is showing a green. Can you see this green? There is a green dot that is showing. So green dot meaning it was already cached till that point and it was executed. But if I go and see the previous top, this top that I did before this, can you see this green? It's not a green, right? So, but if I see the top that is done after a caching, if I see for a take, there is no green. It shows that after flat map, it came and it is done a green and it has stopped over here. That means the caching was done over here, right? The caching was done over here. Can you see this word cache?
Yeah. Yeah.
Okay, but the next time it will just start from there. If you do a top, if you see this, it means that a caching was done over here and it just start executing from here, right? So what does a cache do? It keeps in a memory. What does a cache do? It keeps the things in a memory so that if you note the output of a certain transformation is required multiple times, then it will be executed only one time, right? You don't have to execute it again and again. So if I have to, it will cache in a memory, cache in a memory. So when you execute cache in a memory and will not do flat map again, instead will take from memory, instead will take from memory, right? It will instead take from a memory. Okay, any questions in this?
There should be a time difference as to when we run the top first time without caching and the second time when we run the top with the caching. There has to be a time difference as well, right?
Yes, of course
The
there will
execution.
be a time difference, but it is so small data that we cannot notice it. Of course it will be a time difference, and it's a
Okay.
small operation also. When you have a really big operations, lot of transformations, then you will definitely see a time difference.
Okay.
So I will just take a screenshot over here and
So,
okay.
so does this cache stored in a RAM basically,
Right.
not a hard disk?
Not a hard disk, right?
Hard disk. So and also it is distributed in a same way the way we set up the parallel the cluster means nodes basically worker node.
Right. Each of the nodes it will be stored in a RAM,
Okay.
that particular node. Right. Okay. So where is it stored? In a RAM, right? And if you want to see that, and then you can just say that I want to know the storage level, and you can see that it is stored in a memory. Stored in a memory.
Okay.
Okay, stored in a memory. Okay. So, but what is the problem when you store in a memory? Can I do cache? I mean, what is the advantage? First thing, what is the advantage of doing cache?
It will not using the processing power again
Right. So it will
or
not.
do not doing the action again
Right.
basically.
It will just save some time in unnecessary transformation multiple times. Okay.
Yeah.
So can I do this caching every time before every action? Can I do cache before every action?
No.
Whenever I do a action before that action, can I do always cache?
No.
Memory is limited.
Memory is limited, right? So what need to be there is caution. Okay, memory is limited. So if I still keep on doing, what will happen?
Out
It
of
will
memory.
it will override the last one.
No, it will not override. It will give you memory exception.
Oh, so it will not basically if I do continuously do this caching, it will try to cache actually.
Yeah. So it will always try to cache, and if what do you say, there is no space, then it will just give you exception that out of memory.
Okay.
Okay, so what is a thing? Caution, memory is limited. It will give you a memory exception if you do caching. Okay, just do lot of caching, right? So you have to only do when it is required. Okay. So what is the option? What should be a workaround if I still want to do a cache, but the memory is limited? Then what can I do?
Use the disk.
Sorry,
Use the disk maybe.
use the disk, right? So if you want to do a disk, if I still want to do caching, the answer is use disk. So for disk, use persist. Okay. So I really want you to remember it for a long time. Cache can only be done on a memory, and persist can be done on disk as well. And there are multiple options the persist can be done, right? So if I just do it by default, if I do a persist, it takes as a memory. Okay, if I do a persist, okay, it takes a memory. So okay, but use disk, but for disk you have to use persist. Okay, you cannot use cache. Cache is only for memory. Okay, cache is only for memory. So remember, okay, cache is only for memory. Okay, so what is the option? You have to do a persist, and persist has many options in which you can do. The most common is if you don't specify anything, then it is a memory, and it does the same as what a cache would have done. And you can also specify the option as I think so, storage level dot disk. Okay. Storage level, storage storage level, org dot apache dot spark dot storage level underscore disk is not the thing, disk only. Okay, so there are multiple options like a disk only, memory only. What it says, cannot change the storage level of RDD as it is already assigned to level. What is the opposite of persist? Unpersist or not unpersist? So what it says, applied methods are converted to a function type. You can make this conversion explicitly, right? This unpersist unpersist dot flat book RDD flat book RDD dot, what's the function for persist flat book RDD. So can I see something for opposite of persist over here?
So they said
Unpersist.
Is there? Yeah. Yeah.
So why it was giving some error a while back?
Maybe you need to check the parameter.
Okay, unpersist with a underscore,
Oh.
and let's persist it. A disk only cannot change the storage level of an RDD after it has already been assigned a level. So
Since it has already been cached, this is not allowing, is it?
I don't know. Let's
Cache in
just
memory.
ask Google. Let's ask to Google. Okay, so Stack Overflow. So cache, persist. Is there anything unpersist anywhere? Does the matrix array do any unpersist really hard? As you are getting some persistence from somewhere else in the code, not sure why this is implicit. Calling cache with RDD is memory only while the persist allows you to time the change. So I am guessing RDD has already been persisted somewhere else and you are attempting to re-persist it with cache, which is a problem. However, changing the persistence type with cache is fine. So he's doing uh, model as this, doing a cache, doesn't answer. Unpersist and uncache in Spark. How to uncache an RDD. So let's try. So unpersist only, right? RDD can be uncached by using unpersist. So unpersist. So if I'm doing unpersist, then also it's not happening. The uncache functionality does not exist. I think you are looking for unpersist. The product marks the RDD as non-persistent and removes the RDD from block and memory. So call dot unpersist. So you can refer to spark.apache.org for entire documentation. So why this unpersist is not working? RDD persistence. So as I was saying, for the persist there are different options like this: memory only, memory and disk, memory only serialize, and so on. Memory and disk serialize, disk only, and you can just read what is the meaning out of it. And my thing is about unpersist. Spark automatically monitors, and this, why is this unpersist? If I'm doing unpersist, why it is not allowing me to do a persist? Okay, I have done unpersist and then I do a persist as disk only. Now it is allowing me to do.
It may takes time to.
Yeah, maybe.
That's why last time it didn't work.
Okay, never mind. It should not be that. It should at least go ahead. But it's fine. Anyhow, we did a persist with nothing. Then it was showing us as a memory. Then I had to do unpersist and specify disk only. So uh, you can also do unpersist and unpersist to remove it from persistence and specify as disk only for disk only, and it is disk, and you can basically refer to this particular page for more about what are the different options for persist, right? Any questions in difference between caching and persist?
What is the usage difference? Is the internally they determine how they will use it, and or we have to instruct the RDD how to use it? We don't
Right.
need to do.
So in cache, you cannot give what is the storage level. But let's say you want to cache a lot of things, then in that case you can specify that okay, you can cache in a hard disk instead of caching in a RAM. So the only difference is that in case of persist, you can specify all that options.
Okay, so in that case, why not use persist only, and rather than using cache if that is giving the same benefit?
Yeah, you can use only persist also. That's no issues. I mean, probably the cache came first and persist may came out must have come later on.
Okay.
So you even if you use only the persist with by specifying the memory only, it will do exactly the same thing that what a cache will do.
Yeah. Because it looks like they have a option to memory and disk, so that will be not giving you the out of memory error. Basically, if I continuously doing it,
Yeah,
if you require.
if you give disk, then yeah, it will not give you out of memory
Yeah.
unless your disk is also full.
Yeah. Yeah. So okay, so that means basically when you write a routine, we need to understand when to unpersist as well and clear the area.
Yes, yes. Or else if the job is over, then also it will automatically unpersist.
Does it automatically does it, or we need to put it in the script that we need to unpersist?
Okay, if you want to do within the same program, then you have to do unpersist. But once your job is over, let's say you are making a batch job that does some processing. If that batch job is over, then it will automatically unpersist. But if you are making a streaming job is a job that continuously runs that we are going to see later
Yeah.
on. So if there is some continuous running job that 24/7 it runs, then you have to persist and unpersist accordingly when you want. In case of a
Okay.
batch jobs, uh, if you want, you can. I mean, depending on you, if it is towards the end, till the end, you want something to be a cache, you can also write the last line of the program as uncache or unpersist. But if you don't want, even if the job is over, then it will automatically unpersist anyhow.
And for persist, by default, does it do it in the memory like cache? Because for cache, we don't specify any parameters.
Right,
So
cache
when we,
doesn't have a parameter, and persist also. If you don't specify any parameter, it does in memory. Like over here, we did not specify any parameter; it did in
okay,
memory.
okay. And there's one more question. This one replica means so it persists in the one of the system's memory, and then it also replicates that into another node. Is that it or?
Yes, if yeah, in our case, it's just one system, so it will be always one replica. But internally, yeah, it can have multiple replicas also depending on the replication the Spark feeds.
Okay.
Okay, any other questions? So you can also specify whether you want serialize and deserialize and all. So this is like a very important question for interview as well. I don't think so much is mentioned on this documentation as well for replica. So, but replicates each partition on two clusters. So this is memory only underscore two. So if you specify this particular option, it replicates each partition into two cluster nodes. And so use the replicated storage level if you want fast fault recovery. All the storage level provide full fault tolerance by recomputing lost data, but the replicated ones let you continue with the running task on the RDD without waiting recompute of a lost partition. So if you want a fast recovery, you can also have multiple replicas of the cache. But even if you don't have, if it fails, then it already has a DAG and it will refer to a DAG and recompute everything.
Okay.
Okay. Any other questions?
Can you put this link as well in the document?
Yeah, you can. I mean, you just remember this website spark.apache.org. I will just copy it. But all the Apache documents are over here, and this starting is the project name Spark. I will put in the document as well. But yeah, this is very important interview question. Cache and persist. It's just a one-liner difference. So with this, you surely come to know if the next person has really worked or not. Okay. Any other question? Okay.
Now we are good.
Okay. If no questions here, then we'll end and we'll continue tomorrow with the same time.